afternoon to everyone. This is Ponnoju Vishwasri and my branch is ECE. Today I want to explain about micro-oven simulation using PIC microcontroller, and I have used the microcontroller named as PIC 16F877A microcontroller. This internship was provided by the Emertxe Information Technology. Thank you for the Emertxe for providing a huge knowledge regarding on the microprocessor, microcontroller, timers, and the last is C programming. So now let's enter into the PPT first. Introduction part. The microwave oven was developed in the United States and uses radar technology to heat the food. A microwave oven is considered as an embedded system because of its specific task, controlling the heating process of food with features like power level selection, timer management, and sensor feedback, all managed by a small dedicated microcontroller, making it a prime example of an embedded system. Some of its specializations are dedicated function, sensor and actuators, microcontroller based. Now let's enter into the history part. In the 1947, Raytheon built the first commercial available microwave oven. The compact cavity magnetron tube was invented in the 1940 at Birmingham University in England. It was used during World War II to detect enemy aircrafts and ships. So let's enter into the embedded systems. The embedded system is defined as the combination of hardware and software designed for a specific function. Within the given particular time, the operation will be done. So embedded systems are made up of computer hardware and software. They often include a microprocessor or microcontroller, memory, and input and output devices will be present. The software guides the hardware on how to operate and manage data, and the embedded systems can be programmable or have a fixed functionality. So these are the block diagrams of microcontroller and microprocessor. On the left hand side we can see the diagram of a microcontroller. On the right hand side we can see the diagram of a microprocessor. Block diagram of a microwave oven. Parts of microwave: door, glass plate, filter, touch panel, transformer, magnetron and fan are being present. Advantages: time saving significantly reduces cooking and reheating time compared to traditional ovens. Energy efficient, use less electricity for short cooking times. User friendly, simply controls and make them easy to operate. Versatile function, modern microwaves can grill, bake and defrost in addition to reheating. Compact design, takes up less space, ideal for small kitchens. Even heating, rotating turnables ensure food is heated evenly, and also having safe cooking. Reduces risk of burns associated with open flames. Disadvantages: uneven cooking. Food can heat unevenly within the microwave, requiring stirring or rotating to ensure proper cooking throughout. Nutrition loss. Certain vitamins and minerals can degrade when exposed to excessive microwave heat. Texture changes. Microwaving can alter the texture of food, making it soggy or rubbery, especially with certain types of protein. Overheating risk. Improper usage can lead to food overheating, causing potential burns or damage to the appliances. Moreover, limited cooking methods. Microwaves are not ideal for complex cooking techniques like brewing, crisping or deep frying. Plastic safety concerns. Using non-microwave safe plastic containers can lead to harmful chemicals leaching into food. At last, it is potential for hot spots. Certain food items like liquids can create hot spots within the container, causing uneven heating. Software tools that are used in. These are the software tools that are used in microwave oven project. And the first one is MPLAB X compiler, and the second one is PICSimLab, and the third one is MPLAB X IDE. So these are the pictures and these are the IDs of the software tools of a microwave. So at last we are in the end of the session. Thank you. MPLAB X IDE, and my version is 5.40. My project is on microwave oven, and we can see that there are header files, important files, linker files, source files, libraries and loadables are presented. In the header files we can able to observe the clcd.h, main.h, matrix keypad.h, microoven.h and the timers.h are presented. Moreover, in the source file we can observe that clcd.c, isr.c, main.c, matrix keypad.c, microoven.c and the timers.c are presented. So let's enter through one by one. In the clcd.h we can see that these are the header files of the clcd.h. Moreover, we can able to see that there are ports, data ports are presented, instruction modes are presented, and also different types of ports are presented. Moreover, 8-bit mode, 4-bit mode are also presented in this code. Let's go through the main.h. In the main.h we can able to observe that these power on screen, menu screen, micro mode, grill mode, convention mode, start mode, all these modes are presented. Moreover, we can also display time in main.h, and also reset mode and reset nothing is also been implemented. We can also add the fan DDR, fan, buzzer DDR, buzzer, and also start, stop, pass are been implemented in the main.h code. Let's go through the matrix keypad.h. In the matrix keypad.h, these are the header files of the matrix keypad.h. Moreover, we can able to observe that rows and columns, high, low, state, level are being presented in the matrix keypad.h. Now let's go through the microoven.h. In the microoven.h, these are the header files of the microoven.h, and we implemented with the void loop. Now let's enter through the timers.h. These are the header files of the timers.h, and we are using void loop. Now let's go through the source files, and the first one is clcd.c. These are the header files of the clcd.c, and also we can see that data ports are implemented. Moreover, 8-bit mode in the instruction mode, and also 4-bit modes are also instruction mode are been presented, and this is the code of the clcd.c. Now let's enter into the isr.c. This is the header file of the isr.c, and also we can see that the code has been implemented in the void loop, and also it more indicates of the time which has been using in the nanoseconds, seconds are being implemented. Now let's go through the main.c. Main.c is the important file, and also we can include all the header files here, and also we can also see that whatever the fan, buzzer which are presented in the main.h are been implemented in the main.c. We can also see that micro mode, grill mode, convention mode, display time are being implemented with the initializations. And also we can see that whatever the modes that are presented in the main.h which have a particular program and also particular initializations in their main.c. For power on screen it has an initialization program, for menu screen it has its program. So for every mode it has its own program. For micro mode, display mode, pass, stop, grill mode, all the modes have its own program. So this is the code for the main.c. Now let's enter into the matrix keypad.c. These are the header files of the matrix keypad.c, and also we can able to observe that rows are presented. Rows and columns are also presented. This is the code of the matrix keypad.h. .c. Now let's go through the microoven.c. These are the header files of the microoven.c, and also we can able to see that in the first loop CLCD put CH bar line 1 of I. It indicates that the CLCD in the PICSimLab, it shows first it indicates the bar, second line it indicates the powering on, and the third line it indicates the microwave oven, and in the last line it indicates the bar. This is the first loop and also the first entering screen in an LCD. And also we can able to observe that micro mode, grill mode, convention mode, start are all been presented in the display menu screen. We can able to see that to set a time in minutes is to seconds. For star it indicates the clear, and for hash it indicates the enter. This is the code of microoven.c, where we can able to see that start, resume, pause, stop are also presented in the lines of LCD. And it also indicates that when fan is equals to 0, then it indicates time up. Also it displays enjoy your meal, so that the buzzer will be on. And this is the code of microoven.c. Now let's go through the timers.c and the last timers.c. It indicates header files. These are the header files of the timers.c. We can able to see that it indicates about timers. Thank you. Let's go into the PICSimLab. In this we can have boards, and also we choose the PIC Genios board. Next, the microcontroller is on PIC 16877A. We need to choose, and the file we used to take the loadex file and now open it. Then we can go into the reset button. Now the powering on the microwave has completed. There are micro mode, grill mode, and convention mode, and at last is start mode. We can also change the frequency of clock into 10, 20 as our wish. Now let's press with the we are having the buttons, LEDs, buzzers. Moreover, if we press 1, then the power is 900 watts of power will be gained in the CLCD. Now set time into the minutes to seconds, where we can see that we can use to set the time into 10 seconds. Now, and we used to press the star, and we need to use the hash to end. So if we want to press with the hash, now the cooler is running and the time is up to duration 10 seconds to 0 seconds. Moreover, we can see that after the completion of the seconds, next it will be stopped. The cooler will be running, will be stopped. Now we can see that cooking time is up, and also we can also see that the micro mode, grill mode, convention mode and start mode will be used again. Now next we enter the 2. So in the second we used to indicate one of the time as 5 seconds, and we used to click on the hash. So by that we can see that the cooler will be running again, and we used to pause by using the 5th button. So by using again start or resume, and to stop we use the 6th button. So and the cooking time is up because I stopped in the 6th button. Again it need to came on the macro, grill, convention, start. By pressing the 3rd button, we can see that the temperature, we can able to observe the temperature in Celsius. So we can, as our like, we used to keep the temperature up to 50. So Again by pressing the hash, it time will be start. So 50, 49, 48, again it leads to up to the 0. So we can able to stop by using the pause, and also by using the stop, and by using the reset we can able to come first. So the CLCD is on, powering on the microwave oven. So again we can able to see the micro grill and also all this, and by using the 4 we can also say that start, resume. By 6th we use it to be stop, and also by using again we can able to come to the first. These are the relays that have been presented in the PIC